Well, at this time, I will turn over to Nick, and you can giddy up, and I can operate the slides as you
that'd
need.
be great.
That'd be fine?
That'll be awesome.
Nick, there's a mic right here.
I could use my teacher voice, but if you really want me to use my mic, I definitely will. Hello? Now I'm talking softer than I can without it. Oh, we do have
a
some.
visitor.
Great.
So, Sandra, can you hear us okay? Oh, here she is. Oh, bad connection maybe.
Hello?
That's on her end. Sandra, oh, microphone is still off. Let's see. Sandra, are you, oh, I think it's the microphone on her end. I'm gonna go ahead and mute you, Sandra. Your microphone is really staticky.
Can you?
Oh, hang on. Try again. Can you hear us?
Can you hear me?
We can.
Okay, it was hard to hear the video. It's better when you send it out beforehand
Yeah.
to watch.
Yes, I should have done it. It's the same address as always, the zoom.knoxsciencecafe.org, but I should have sent it to you. I'm sorry, Sandra.
Oh, okay. Okay, but yeah, I can hear you fine now.
Okay, well, good. Raise your hand or do the indication on Zoom when you have a question, but I'll let our speaker go ahead and talk for now. I'll go ahead and mute you, okay?
Okay.
All right. Let me turn this where she can see. There we go.
Could you put up the slide?
Absolutely. Okay. Slides. Browser. Okay.
So this is,
A quick, I don't think the screen is being shared either. A quick,
he's kind of showing it
oh,
on the webcam.
gotcha. That makes sense. Sorry.
Good catch there.
At the moment,
At the
yeah.
moment, yes. All right, so welcome to the STEM education overview. Thank you so much for attending as presenters or participants. This is also acting as our regional STEM hub meeting as well. So I appreciate partnering with STFK. And if we just move on to the next slide here. So we're just gonna kind of introduce ourselves as we talk about our STEM journeys and the different majors and/or jobs that we have currently. We've already watched the video, so that's great. So we do have 7 guest speakers besides myself, ranging from lecturers, undergraduate students, as well as grad students. And I am a postdoctoral research associate, so I'm kind of in the middle of that, I guess. But I did graduate with my PhD last spring. So if we move 2 slides ahead, I'll talk a little bit about my journey, so just kind of give you an idea of what's going on. So I just brought up a bunch of pictures that I have throughout my life because I felt like pictures can really speak louder than words, and sometimes you just seeing a picture is a little bit better anyway. So I am a soccer coach. I still coach soccer at West High School. That's where I actually taught. I was a math teacher for 7, 8 years. And then I'm still coaching. I'm coaching boys soccer now. But at that time, I was coaching girls soccer. Like I said before, I just graduated with my doctorate in STEM education, really focusing more on math education. I'm also an active golfer, so I have a picture of my dad and myself here. I have 1 dog now. His name is Nemo. He's a Shepherd Husky mix. My wife, Sharon, is here as well. I'm actually from Nashville, so I have a skyline picture from Nashville. I went to a STEM magnet school, and I thought going to college and becoming a teacher that people were like me when I was in high school, but it's very drastically different from those who go to a STEM-associated magnet school. But it was a great learning experience because I had to go a little bit outside the box because I originally was an accounting major, and I went through the business administration degree, did that for a year after I graduated, absolutely hated it because I was just sitting at a desk and just crunching numbers, which I was fine with the numbers part because I do enjoy math, but it wasn't really doing mathematics, it was putting it into a database and just kind of crunching out my numbers that way. So it wasn't as fulfilling, and then I decided to go back and become a STEM teacher. The funny thing was I actually was asked to speak to a senior in high school level youth group, and they asked me, we were talking completely off topic about what I was supposed to be talking to as the leader for that group, but we were just talking about education in general, and I was really, really moved by their knowledge and their experiences, and I was just blown away by what they were saying. So I decided to go back and pursue my degree in math education and got my master's and now my doctorate in math education as well too. So it's been a journey. It's all been in Knoxville. It's all been at UT. So that's really all I know, other than my accounting stuff that I did outside and in Nashville, just growing up in high school. Oh, excellent. That works too.
Yep, all right. So, oops. Sorry,
Oh, you're
learning,
good.
I'm
No,
learning.
you're good. I also am
There we
like
go.
really, really, really into sports, so that's why I had on my last slide there, I had a lot of pictures of the Tennessee sports teams that I really enjoy. I'm gonna pass it on to Matt. This was in no particular order, it's just people sent me things and I went ahead and I put their slides on here. Some speakers do not have slides, they're just gonna talk about their experience, which was completely okay with the process as well too. So I'm gonna pass it over to Matt.
Howdy. My name's Matt Lane, and I don't have any cool pictures. I'm from St. Louis, and I initially went to, did my undergrad at Mizzou. I actually wanted to go to med school. I thought, let me rephrase that. I thought I wanted to go to med school, but I was a music student, and then I shouted a bunch of doctors and realized that I really hate the sight of blood. And so I was like, oh my gosh, no, absolutely not. So then I wound up just doing a philosophy degree because, naturally music and medicine means philosophy. Not quite sure why I did that, but that was what I did when I was 22. And then I wound up moving out to California and just working at a startup for a quick moment. It wasn't very exciting, which that's not on the slide there, but from there I actually wound up taking my love of bugs and working at the Missouri Botanical Gardens and doing a lot of education outreach with that and teaching kids in the community to preferably not kill bugs when you see them, which also, please don't kill bugs when you see them. They're very kind little creatures who, they just want to live their lives and pollinate flowers and whatnot. After that though, I did miss the rigorous world of mathematics, weirdly. So I ended up going back to school, pursuing, a master's in computer science, because I thought, I like computers, I like math, it's very fun, and I just happened to know my advisor at the time, and she was working on Alzheimer's disease research, which was extremely fascinating, so I did that for a couple of years, and then went to go work for Bayer Crop Science, and to write applications to basically see how we could better predict and better feed the world. That's like the big overarching thing. We're making a lot of soy products and corn products, which is mostly grain feed. But it was a really good time. I learned a ton about how to properly code things and to basically build giant software applications. But then again, got very sad and I missed the more rigorous world of math, which there's a weird theme here. And so here I am now in Knoxville, Tennessee, at the Bredesen Center, which I didn't even think to put a cool little slide there. The Bredesen Center is an interdisciplinary research organization. It's not an actual, I guess it is technically a department, but it's not like the math department or the CS department or the English department. It's just its own tiny little corner that the goal is to just sort of put students where they can fit, and basically just let us spread our wings, which sounds cliche. But so we take a lot of classes in engineering, in literally anything we so please, so long as we can reasonably defend it. And so very long story short, I'm so sorry, I'm just gonna keep rambling unless someone crowds me off here, it'd be a cane. I work in computational biology now, where we do a lot of genetics research. And I implement the code that I've learned from previous positions, and the exciting biology that I learned in undergrad, and the math that I very much love. That's what I do.
Can we go back to your slide?
Oh, yeah.
I'm sorry, I didn't realize you had a slide, or I would have had it up
Oh.
here.
And then,
Is
yeah,
this
so
your slide
this is the timeline. It's very,
very
I was gonna say it's very linear. That makes no, I mean, time, yeah.
Hang on, let me turn the screen share back on.
Oh.
There we go.
Perfect. And then this is my advisor, Dan Jacobson at Oak. And oh yes, I work under Dan out at Oak Ridge. It's a very good time. Yes.
Can you say anything about the importance of bugs in agriculture?
Oh, absolutely. I mean, pollinators are. I forget the actual numbers, and if someone knows the numbers off the top of their head, please just shout it. Pollinators are basically the backbone of our entire agricultural system. We use a lot of honeybees. Honeybees are amazing. They're just not native to the Americas or, well, many places in the world. But we do use those for lots of monoculture farming, which is not bad, but not always ideal. Bees don't love being trucked around. Like, I would really hate it if somebody picked my house up and then drove me across country and was like, here's your job now. Like, I would be a little grumpy. Bees get grumpy too. I'm just rambling. Bees are great, but honeybees are great. But local pollinators, such as the things you see in your garden, be them butterflies or local butterflies, local bees, even beetles. Lots of beetles love to just chill and sleep in flowers and eat pollen. Very adorable. All bugs are great. If you happen to have a tiny little area of your garden, if you could just take some dead bamboo, just shove it in a little corner. Lots of local bugs love to live in those little holes. So please save the bugs. What's up? Yes.
Is it 3 out of every 4 bites of food is thanks to a pollinator?
I think that's the actual, what is that statistic? I always forget if it's like 3 out of 4, like even maybe more. Like it's scary. If we don't take care of the bugs, then we're gonna have to eat a lot less. And I enjoy it's the best. But
So since we know that, why does the USDA permit so much
ooh,
poisoning of bugs?
that is above my pay grade. I don't know. Money, I suppose. Neonicotinoids work really, really well as a what's the word? Pesticide. And there are also a lot of bugs that we don't really want a lot of weevils eating all of our corn, because then sometimes they would we wouldn't have anything to harvest, and then we'd run out of that. It is a unfortunately horribly complex problem. There are a lot of people trying to solve that though. There's a group up in Louisville who actually they started building vertical farms that are inside of structures that are hermetically sealed, but then B, they have basically these beautifully large, like sort of geodesic dome farms that they can sort of monitor very, very closely to make sure that A, bad bugs don't get in, and B, that they're not spraying tons of rough chemicals everywhere, because that's not ideal. But
Perhaps you'd be interested to come to a science cafe. And
Sure,
be our
yeah.
leader. I've actually been searching for, what was it, when they first announced that bees were endangered or in danger of becoming drastically reduced. That was the 2013 timeframe. I've actually was looking for a speaker during that time, couldn't find anyone. And then about 3 to 4 years ago, right before COVID, they were saying they were bouncing back. And then I started looking for a speaker again. So you came to town,
just a few years too late.
just missed it.
Yeah.
So it just
Always
now you got me curious. Are they indeed the pollinators bouncing back? Is this a phenomenon, or is this cycle? or-
Honestly, no.
Don't
It's
know,
been a
okay.
few years since I've been out of the
Alright.
actual bug world.
Okay, I
I've been
got you.
working more like
You've been-
at the genome level, which is sad. I used to have a big old tarantula. I had a giant millipede that she was like a foot and a half long, which I know makes some people's skin crawl.
Well, now.
Mildred the millipede was the best.
So maybe between now and when we have you come talk, you can build a computer model about, and
Perfect,
if they are,
yes,
if they
absolutely.
are, bouncing back or not, there you go.
Oh, always happy to do that. Are there any other questions, or I can also just hand it off and we can talk about it?
One
Yeah,
more.
please.
Restorative farming,
Yeah, absolutely.
a word or two?
It's great. Highly recommend. No, sorry. I'm personally not a farmer per se. I just like to play with bugs. But yeah, taking lots of local plants. There's a researcher out of Washington University in St. Louis named Natalie Mueller, and she does a lot of work with. Oh my gosh. It's restorative farming, but it's also lots of lost crop farming as well, taking burned seeds from a lot of Native American lots of dig sites where you can see what Native Americans were eating prior to the colonists coming over. And so basically using those, because there were tons of grains in the US, like quinoa, that people used to eat, and it was just local and great for the environment, but we lost it.
There's a very good YouTube about restorative farming, probably more than one.
Oh, I'm sure, yeah. Awesome. I'll have to check that out. Yeah, I'll have to also reach out to Natalie. I'm sure she has a bunch of good material on that as well.
Thank you.
Yeah.
I think Amanda was next on the slides. She actually had a different website she
Oh.
went to.
So we need to look something else.
You just go to her slide and the link is on the
I
actual.
am very
okay.
loud.
Oh.
I don't know if we really need to, I mean, just naturally, I am terrifyingly loud.
on the-
Well, it would be very difficult for our Zoom guests to hear you without,
Oh,
so your voice
Is
is
she
coming
in
to
the
this.
state? Because she probably could still.
I don't think so, actually, so I haven't asked in a while.
If we just copy it.
Okay, so there's
On the bottom, it's fine.
right here,
too.
this link?
Either one, yeah, either one.
Okay.
She has her own story map.
We're at the right place?
Okay. Well, hi, my name is Amanda Garner. I am currently a PhD student, science-focused STEM at UT. I have been a middle school science teacher and math, mostly science, for 15 years. If you would have said to me when I was in high school that you are going to do the things that you do with education, I would have said you're a liar and full of it. Because I hated science and math. I was always told that because I was a girl, I wasn't allowed to be good at it. Okay? When I struggled, I was told that, and I see some of your faces, some of you probably had that experience as well. I was told that it's okay that you're not good at math, you're a girl. Well, I believed that for a long time, and then I went to college and I got into a teacher education program, and I found out something. I'm great at science, and I'm pretty darn good at math, so that kind of started my journey. So, like I said, I have been teaching for 15 years. If you want to scroll. In 2008, I did a teacher internship with Tremont Institute at the Great Smoky Mountains National Park. This was after my first year of teaching, and I was going to get paid, honestly, and I thought that was great. So I went in, and man, my eyes were open to the possibilities that we can do with our kids in our schoolyard. So I went out, and I was one of the first groups to scrape traps for the emerald ash borer. Have you heard of the emerald ash borer? Yeah. I went out with those sticky traps every week, right? We would scrape. We would collect specimens and send them to the lab to be identified, or we would try to identify. I actually was with a group that first placed the Appalachian pearl butterfly in the park. We already knew it existed, but it was there. Man, that was a great day. So I'm a part of Discover Life in America. If you don't know anything about Discover Life in America, it is tremendous. And from there, I thought, why can I not do this with kids at school? So that started my journey in utilizing community and school resources to teach science. So I am a place-based educator, which means that I utilize the resources that we have in our community and in our schoolyard to teach. Oh,
So you want me to go back up? Okay.
Keep going.
Oh, my bad.
Okay, yeah, go down a little bit. One of the groups that I work with is the the Great Smoky Mountains National Park. I work with the National Park Service on one, I work with them, they come and help out with kids. We go and do field trips there. I help them with curriculum and teacher education. I started that many, many years ago, and it has been incredibly fulfilling. I've also worked with Tremont, specifically with citizen science and teaching citizen science to other educators. You can scroll. I have worked with Keep Blunt Beautiful in the Soil Conservation District. Through that, we were able to get a very substantial grant to plant native trees on our campus. If you know anything about schoolyards, they are over manicured and very, very difficult to plant trees. That was a difficult day, but the kids got out and planted, and they owned it, and they weeded them. And we went outside and they took ownership of those trees, which was very, very important. It was also a great way to highlight some of the native species and make that a part of our campus. I've also done that with Soil Conservation District. I have done teacher education with them as well. I've worked with Discover Life in America. We have an iNaturalist project where our students go out and collect data on our schoolyard. If you ever want an interesting look, go to iNaturalist and look at areas that are considered redlined or low income. You will not see a lot of marks or pinpoints of data for biodiversity. Does that mean there's nothing there? No. My school is in a low-income area, and we have 236 different species that we've identified on our campus. The coolest thing, you wait for this, my kids found a millipede. A millipede. We took a picture, we loaded it, we got contacted by a lab in West. See, you like the bugs. I'm gonna talk more about it in just a second. I love the bugs. We got contacted by a lab at West Virginia. They want to come to our campus because it's such a rare millipede. It's only been found in like 2 other places. And our kids found it. Our kids are obsessed with millipedes now. How many of you know 7th graders that are obsessed with millipedes? Like, it's nuts. So I cannot emphasize enough like the importance of like working with different groups and utilizing tools. I'm also a Grosvenor Teacher Fellow through the National Geographic and Lindblad expeditions. In 1 month, I will be on an expedition to the Galapagos. Yes. They do that where they send 50 teachers. So I was chosen in 2020. Yeah, guess what? I still haven't got to go until next month. Among 50 educators in North America, and we're chosen for the work that we do, and mine was how I use place-based education in my community and teach teachers how to utilize it as well. I have done, Oak Ridge National Labs, I have partnered with them. One of the best things to have is the engineers or the scientists do the Zoom calls with our students. My kids don't have lots of chances in life. They have a very hard life of where we're at, but when they get to talk to scientists and see what they do, they talk to the engineers, and it gets them excited about it, like that's something that they want to do, and being able to converse with that. So working with Oak Ridge has been very, very important as well. I have been lucky enough to do professional developments with Teacher Now internationally. I got to work with teachers in the Philippines about place-based education and utilizing their schoolyards. And most recently, you're going to love this. Matt's going to love this. It's Matt, right? And Educators for Animals Conference, where I spoke about explicitly teaching empathy for animals in your classroom. We do not squish bugs. We take their pictures, we put them on iNaturalist, we name them, and we take them out, right? But that is very, can you go back?
Yeah.
Yeah. So that is very, very important. To get you, see some of the stuff that I've been able to do, if you can scroll up. This is the bridge that is in Foothills Parkway, the new one that took, I don't know, from the 60s to a couple of years ago to do. The engineers of that bridge came and talked to our kids. We made lessons with it. Our kids were the first group of people, besides the governor, on this bridge. So we were on it, and they got to see how it was created to allow wildlife to go through, and they got to do some programs with the park rangers. Can you go to the side?
Oh, go to the side.
Yes. Can you
Is there a
click that?
link? Oh,
This is us working with Soil Conservation District and our kids trying to dig up to put our trees in. Here's some volunteers from the military that came to help care for the trees, because at this point I was carrying pickle buckets of water around our campus to water them once a week. So they kindly enough came to help. We had American Heritage Girls build us some picnic tables, so we had better access near our pond to be able to work there. That's it? Okay, you can scroll down. There we go. And keep going. I totally believe in field work as a professional development. I have worked with scientists in the national park. Here I am helping shock fish, not by telling them bad jokes, but with electricity and our rubber waders, if you can go over to the side. And I got to work with other teachers there as well. Air quality station up at Cove Mountain, I got to go up and take a look at that and work with some rangers there. Okay, that is a salamander. I was a part of research where we took DNA samples from the tips of Jordan's red cheeks and pygmy salamanders in the park in 2 different locations. I was lucky enough, because of my experience, to get to lead one of those with a group. And just this March, they presented their data in the science colloquial at the park, which was really neat. I got to tag baby newborn elk, which is thrilling, and elk are terrifying. And again, with the native fish study. Oh, yeah, there I am, fish. Oh, I got to do firefighting training as well. So all of these have kind of made me who I am. People don't think that teachers get to do things like this, but there's many opportunities for that. And the Park Service is an excellent one for that.
before we go on, what is the purpose of shocking the fish? What are we doing?
Counting brook trout. So they're trying to, brook trout are native, but there's also brown and rainbow trout, and rainbow trout are taking over, well, we shocked them and found a brown trout with a brook trout in its mouth mid-eat, right? So they're taking up the native populations and kind of, they're trying to see if they need to clear out the rainbow and the brown trout in order to make room for the brook trout, which are native, because rainbow trout are not native.
So you're delivering electricity, what, to get them to come out from the rocks, or what is
Oh, you run it through, it shocks them and they float to the top. You gather them into a bucket, you rub something on them, you measure them, and then you wake them up and put them back.
I see, okay.
Yeah.
It's a anesthesia.
Yes.
Okay, all right. That seemed rather cruel. I was like, what are you doing out there?
Well, yeah, no. They live, there's very few fatalities with it. The goal is not to hurt the native species with that.
I didn't think that was the case, but we just wanted to clarify for the kids here, okay.
And here is our school campus, and these are all pinpoints of data that the kids have collected. You can see, look at the surrounding areas. This was taken I snapped this a couple of years ago. You will now see it out in these neighborhoods because the kids are now doing it on their own. Okay, we can keep going. And here's some stuff. I explicitly teach kids how to catch things, to look at, study, and release. I can happily say in my 15 years of teaching, we've only had 2 fatalities, and one of that, the moth really tried to get away and the kids were very upset, so I'm sorry about that. You can go over. We do pond inventory, so we not only do the things that we can see, we use microscopes to look at the water in our pond to identify things there. We look at lichens to determine air quality for our campus. Okay, and that's us doing a lichen study, and this is the exact same study that they do in the national park. That's a little friend that was under our snail plot. And there we are doing a community bio blitz, which we would invite the community out and our iNaturalists. We've made it to the paper a few times, which is a big win. Okay. We've had Park Service employees come to do work with them. I get the kids into the pond. That was the picture before. We do a macroinvertebrate study to determine the quality of our pond. So the kids get in, we get them out, we identify them, we iNaturalist, collect the data, and then release them back in. Oh, and that's one of our blood worms that we found. It was so weird, amazing. With dragonfly larvae, which we learned very quickly, you need to make sure it's separate. We got some millipede, this is our snail plot, and actually, most recently, our kids discovered that there was an invasive species, the hammerhead worm or the shovel-headed worm. We found 2 of them under our snail plot. Some of our fancy rare millipedes that haven't gotten their color yet. Okay.
Scroll it.
And you can keep going.
Okay. Oh, that's the end.
Okay, then that's it. So does anybody have any questions?
Wow, where to start?
How often do your students get to do these outdoor projects? Or like, not just outdoors, any of the projects, that can, like, because that's, I am very envious. It seems like you have a really awesome grasp of like everything going on around.
All through the year. So we do, when it's too cold, we do the pond inventory with the water. The kids get out into the pond twice a year. We do 2 bio blitzes, we do a pollinator blitz, we do lichens once a year. We continuously look at snails and our snail data for our snail plots. And then if we just need a break, we go out and we iNaturalist. Little mini bio blitzes. And we use that data to analyze for different things to support the curriculum and standards.
Super cool.
And tell me again, what's the, you mentioned there are underprivileged children in the area. What is the school that you're working with, or the organization? Where is your sphere of influence here?
I'd prefer not to say on the video.
Okay, all right.
But we are a county school. We
Okay,
are a county school.
it's a county school. Okay.
And our population, it's high for that. So that's my mission in life, is to make sure that all students understand that STEM is accessible to them. I want them excited about it, and I want them to see that in their future. Most recently, I got an email from a student that I had. He's a junior in college now. Don't tell anybody that. I know we've got it on video now, because I can't be that old. But he's going into marine biology. I recently had a graduate go into computer science. I'm not a computer science specialist, but things that we did, she said, inspired her. I have a veterinarian. And these are all kids that many would say didn't have a future. And I feel like I had a very small, not the whole part, but a very small part in that.
So so the kids are directly engaging with the environment, taking the data. What are you doing to carry that and introducing the technology aspect, or the engineering or the math aspect of that? Are you like, are the kids doing reports, or what's crossing the disciplines there?
Okay, so I'll give you one example. We do several things, but one example is we teamed up with a scientist. She's a coleopterist in the Philippines, so she studies beetles.
Mm-hmm.
So she mentored our kids. We did a beetle survey on our campus. We learned about it, but then she talked to them about how to safely trap beetles. So she said what kind of traps that they used. They researched on their own and tried to come up with ways to build their own traps in a humane way. They weren't all successful, but it was a learning curve, and we did a great job with that. So we always try to find a way for it to translate, one, into the standards I have to teach as required by the state, right? But also a way to inspire their curiosity, make them excited, and take action within the community. We want them to be good stewards of our planet.
That's fantastic.
Yeah, I do.
Go ahead, go next. Oh, go ahead, Matt.
Oh, I said, so just piggybacking off of a technology note, are you or do you have any intentions of doing, integrating any of like the, I don't know, it's a coding-based thinking, I forget what it's called, the new, oh my gosh, I was just at this thing last week, I can't remember, the new initiative for Tennessee to introduce technological based thinking, problem solving into any classroom. Like, do you by any chance remember what that was called? I can't, my brain is melting.
Is it like CS for all, right?
Yes, yeah, it's the CS for all, that like TSIN is currently sort of working, or TSIN is currently working to sort of integrate into pretty much the entirety of the education track. Or if you've even heard of it, I don't know.
Well, I have done coding with my students in the past. I worked with a STEM teacher. The strength is not coding. I'm actually taking a course with that now. I'm taking R. Yeah, I'm working very hard on it. But we were with the STEM teacher who had a 3D printer, so the kids would build, like we would learn things in class and take the information, and then they would design in Tinkercad, and create it with a 3D printer. I will always team with people who know way more than I do. That's why I've done so much stuff, because, you know, we can't all know everything, right?
That's super cool.
Thank you.
Sorry about that, I think I went over.
That's okay. That's a good leadway because I was one of those students. I had a teacher a lot like you who couldn't take no for an answer. And she got us involved in everything. I got to do forestry. In high school, I got to do forestry experiments. I got to do soil sampling. I got to do bug surveys. I got to do wildlife identification. I got to do all these special topics in environmental, and then we switched over to robotics. And I got to build robotics. I got to go to international robotics competitions. Usually we failed horribly, but it was a great learning experience. And she just did. She really opened up science and math and taught me that it doesn't matter what anybody thinks. If I can do it, I can do it. And so that kind of started me. She wrote me letters of recommendation for college. She got me, I'm first gen, so she got me to try college. She got me to go to college. I went for college, and the hardest thing about going to college was trying to decide which major I wanted to go, because so much of science was interesting. It's like a candy land at that point. So I stuck with no decision and did the undeclared major at my college, which was mechanical engineering. And so I went to New Mexico Tech for mechanical engineering, had an internship at Oak Ridge National Lab over one summer, and that opened up a whole other, Oak Ridge is a huge candy store for science. There's all kinds of cool stuff. I met a lot of cool people, had a lot of great discussions that summer, and went back, graduated, and just reached out to some of the people I'd met at Oak Ridge and was like, hey, I graduated. Do you have that bibliography for that paper we worked on? And they're like, how about an internship for 2 years instead? And I went, sure, that sounds even better. So I came out to Oak Ridge, worked there for 2 years, and really did some digging, explored what I really wanted to do is, when I grow up. And landed at the Bredesen Center, and it's really cool because it is that interdisciplinary, we get to study all kinds of things as long as we can justify it. That's the key. And it's a really great program. It opens up between different disciplines. So I have friends who are in data science who've had to take biology classes because they need the background for their research. I've had biology majors have to take data science classes because they need the background for their research. So it's really cool. I'm really happy to be here, and hopefully someday I can say I've officially decided what I want to be when I grow up.
What is your doctorate?
My doctorate is data science and engineering. Yeah, kind of switched from the mechie, but opportunity arose and I took it. So
Maybe you can help me with my coding and my...
oh man, I'd be happy to. I'd be happy to Zoom class reference too. So yeah. Go for it.
What did you do with your robotics team? What was the?
We did a couple different competitions. So the one that we participated most often in was just the one hosted by MESA. So it's Mathematics, Engineering, Science Achievement. And they do a competition that just uses the Lego Mindstorms, or they did at that time. And so it's the visual block-based coding. It's gets you used to the ideas of it, and it's very similar to some of the visual-based codings you'll use in industry like LabVIEW, etc. But way simplified. And so there are a certain number of components. You can add motors, you can add sensors. The challenges we usually had to do was it was a white mat with a black line, and you have to follow the black line that has dead ends and wrong turns. to get a payload to a station. And the more times you could do that with the larger the payload, the more points you got. And then part of that competition was also you had to document your design, and you had to submit like design paperwork that went with it. So it was really great from learning how to do engineering and technical writing all in one event. Yeah, it was pretty cool. And then we participated in some local ones too. But yeah. Who's next on the
Would
queue?
you like to go next?
Sure. And I'm so sorry, but I have to bolt for another engagement, so.
Thank you for coming.
I didn't bring slides, I brought a prop.
Even better.
So apparently I have a freakishly linear path into my field. As many people in paleontology apparently have done, I decided when I was 5 years old I was going to be a paleontologist. And I had a little bit of a detour in middle school where I was like, well, maybe I'll do Egyptology. And then by the time I was in high school, I'm like, no, paleontology. So I showed up at the University of Tennessee, it's a local girl, which is fun because I'm back home teaching. And I knew I wanted to do paleo, so okay, what department do I go into? Well, the only paleontologists on campus were, at the time it was called, I believe, the Geosciences. They keep changing their name on it. We're right now Earth and Planetary Sciences. Majored in that, minored in biology, and got involved in a couple undergraduate research projects while I was there. Some of them were very paleo-based, others were just to get experience sort of in the lab. So I ended up in behavioral psychology, cleaning up snake cages, and you can actually find me in an acknowledgement section of a PhD student at the time, their dissertation, because it's like, yep, she got to count scales on dead snakes for a very long time. But I had sort of one of those life-changing classes, but just mine happened to be an undergrad. It was my last year. I'd already been accepted into graduate school at this point, so I already knew where I was going. It was definitely kind of a senioritis situation, but I needed just one more credit to check off the box to get all those distributive requirements out of the way. And I said, well, you're at the University of Tennessee. They have an internationally renowned forensic anthropology program. Why the heck not? That involves bones. We'll have some fun with this. And I took this class, and I kind of fell madly in love with parts of it. So I became absolutely fascinated with what we call bone surface modification, which is exactly what it sounds like on the tin. It's all the different things that can mark up, degrade, destroy, whatever alterations you want to think of, anything like that to the surface of bone. Obviously, this was being taught in a medical legal standpoint, but I can see very easily how this could be applied in paleontology, and I chuckle at this point because my term paper in that class was actually on vertebrate bite marks from a forensics point of view. So I get to my graduate school. I went to the University of Iowa, and my initial project, for a number of reasons, was not working out, and I ended up going to my advisor and saying, I couldn't help but notice when I was doing that term paper that I'm still obsessing about, that almost all of the research was done in a forensic framework or in an archaeological framework, zooarchaeology, paleoanthropology, and that's all kind of recent. So what that means is most of the animals these researchers were concerned with were mammals. And I was never in it for the mammals, I was always in it for the reptiles, so I said, can I do this? And the next thing I knew, I was doing my PhD dissertation on crocodilian bite marks. So 2013, I came back home, came back to Tennessee. It just sort of happened to work out that the department here was needing someone to fill in because they had multiple people on sabbatical that semester. So I came in and started teaching, and then after everybody came back from sabbatical, they just kept me around. So I've been teaching in Earth and Planetary Sciences since 2013 and continuing to do research. But one of the things about vertebrate paleontology, we tend to take our public outreach aggressively seriously because I feel like all of us on some level feel like we might have run a scam on the universe. It's like I'm literally playing with fossils professionally. I gotta get back. So I try very hard to do things like classroom visits and Zoom meetings And I usually have a little army of undergraduate researchers following me around doing projects. So, and I try as hard as I can to involve them all the way up through publication. So I've had multiple papers at this point that have had undergraduates as co-authors who have made it all the way through the project, all the way through peer review, all that fun stuff, all the way to getting it out there in the wild. So I'm still doing that today. It's still very much education, outreach, and research on my end of things. My fun toy that I brought is talking about like when are things going to be posted? Technically, the paper comes out tomorrow at 2 p.m., so that's when the embargo is lifted. I've been working on a dinosaur mummy of all ridiculous things. This is actually a 3D print of its hand. We did some CT scanning. This is just for me to run around and hand to people and play with, but I have 2 undergraduates right now who are virtually dissecting out bones that are still on the inside. So we had to come up with some creative, how do you do undergraduate research when no one's allowed to come in the lab for the last 2 years? So we love our CT data because there's plenty of shareware programs that you can play with that. But that's coming out tomorrow, so I keep getting sort of tripped into more and more dinosaur projects. I started very much in the croc side of things and somehow ended up playing with lots of meat-eating dinosaurs. So that's my weirdly linear path. So with my one weird hiccup of forensics.
Is a dinosaur, what's the difference between a dinosaur mummy and a dinosaur fossil?
All right, it is fossilized. So you hear mummy and that gets kind of dangerous because then people immediately think of Egyptian mummies and it's like, no.
My first thought.
A naturally occurring mummy, usually what we're talking about is it dried out in some way.
Cool.
So the weird question though is from a paleontological point of view, how do you get to that step of fossilization? Because modern stuff drying out happens all the time, but the next step, how does it actually lithify, is the weird part. So for the gist behind this paper is less about you look at the mummy and more how on earth did it fossilize in the first place. Because we used to think that you had to be rapidly buried. And it's one of these fuzzy terms where we do a really bad job of defining it. But when we do in the literature, it's usually immediately at or immediately after time of death. Like just stash that thing underground as fast as possible, get it away from the predators and scavengers, get it into a situation where it's going to eat up all the oxygen quickly, and then the microbes kind of peter out, so you can freeze that decomposition in place, and then it'll fossilize. Except this thing, and until 2 p.m. tomorrow, it's got bite marks all over it. Why was I called in on this project? Because the researcher called me and was like, I think we have bite marks on soft tissue, which was amazing and viscerally upsetting all at the same time, because that was one of those things that's explicitly stated in the prior literature that says if scavengers and predators get to it, it's not going to fossilize. It's too degraded at that point. But you go back again, well, where was my turning point? You go back to the forensics literature, and there's actually a pretty extensive body of work looking at what happens to things like skin. And I have to remind myself that what I do is gross sometimes and dial it back a notch. But basically, if you compromise the body wall, if you poke holes in the body wall, all of the fluids and gases related to decomposition have a way to get out, and then the skin gets left behind. So if you're after internal tissues, if you're after muscles, if you're after the digestive tract, you are out of luck with this specimen. But if you want the dermal tissues, if you want beautiful skin, if you want nails, and this is actually a fairly common way that things progress through decomposition just naturally, as described in forensics. It just hasn't really been discussed much on the paleo side of things. Because we do get some soft tissue, and we always get very excited when non-mineralized tissues end up in the fossil record, but it's usually a weird path. So dinosaur mummies are more common than you might think. This kind of helps explain that. It's a very normal process that could lead to it becoming buried. But it's still been a bit of a mystery in terms of how did it even happen in the first place. Because that fossil, it's currently on display in North Dakota where it was found. So that's why you're not going to let me bring a dinosaur mummy arm in, alas. But it's nearly complete. We're missing one arm, we're missing the head, and we've got skin on the remaining arm, both legs, the tail, parts of the body, but they're still preparing it. So we wrote a grant that was to a private foundation that very explicitly is like, we want to fund research and we want to fund education and public outreach. So we've got interns coming in who are being taught how to do the preparation work, how do you get the rock off of this. I've got my students who are working on sectioning out the CT scans, we're going to be doing chemical testing, and at every step we're pulling students in.
Just kidding.
No worries.
How do you get the rock off of that?
Very carefully. No, there's actually there's a literal career that I feel deserves way more love than it gets, called fossil preparator. There's this idea that we go out in the field and we get the fossil and we bring it back and we immediately research it. And sometimes you can do that. Like sometimes the fossil comes out of fairly loose sediment, but not always. So this one is actually within a very hard sandstone that has iron minerals in it to make it extra hard. And basically what happens is the fossil preparators have air abrasive tools and they have to hand remove it. So, you're talking about not remembering numbers. I can't remember if it was 1,400 or 14,000 hours. I think it might be 14,000 that have already been put into this fossil just trying to get the rock off the silly thing. And they're not done yet. So it's, when you go to a museum and you see a dinosaur on display, someone spent months of their life cleaning that up, getting all the sediment off to expose the tools underneath. So, and then there's people like, I had a professor that all of his fossils were what we call silicified. They were replaced with naturally occurring glass. So he would throw the rock in a bucket with hydrochloric acid and come back a few hours later and all of his fossils would be there, and we hated him for it. I'm so jealous. But that's fossils. There's many different pathways to get to what we would call a fossil, chemically speaking. All right. Any other questions?
Hey, Allie, you're next. We actually have one more slide, but 3 more people, so
I will be
we're running out of time.
Okay, well, hi everyone, I'm Allie. I'm a graduate student at UT, so I'll just talk about how I got this far. So I'm from Shenandoah County, Virginia, which is, if you've ever been, it's very beautiful, but there's not a lot there. I think my hometown has only like 1,000 people. But one thing we did have was access to the whole region's STEM magnet school. So I got to go there in high school, and that was actually my first kind of like STEM foray, and I got to do water quality testing. But my favorite thing to learn about was we started learning about climate change, which of course back then wasn't as, we didn't know as much, but now it's much more popular. And so then upon graduation, I went to the best school in Virginia, Virginia Tech. And I decided that I would major in environmental planning because I really wanted to learn more about the intersection between environmental problems and people. And then ultimately that led to me doing my first internship at Oak Ridge. And that was kind of the first time where I thought, oh wow, maybe I'm actually good at this and I could really, go somewhere with this. So I went back to Virginia Tech and I got a master's degree focusing on disaster resilience. Living for about 5 years in Southwest Virginia, there's a lot of poverty there. There's also a lot of flooding. So I focused on improving flood modeling and prediction methods for communities that don't have a lot of resources, as well as figuring out how do we better access people who don't have cars, they don't have internet or cell phones, because in previous years with those floods, people had not gotten access to emergency response warnings ahead of time, and there had been significantly more damage because of that. So anyway, after graduating, I thought, oh my gosh, what am I going to do? It's the pandemic, no one's hiring. So I came here, no, I'm just kidding. I came here to the Bredesen Center because I wanted to, and I'm doing my PhD in energy science and engineering. And my favorite part about it is that I get to work with the Geospatial Science and Human Security Division at Oak Ridge with my advisor, Budu Badiri, and my other advisor, Liam Tran. And now, instead of flooding, I'm focusing on winter storm, improving winter storm modeling and prediction so that we can better understand and plan for its impact on vulnerable communities.
I understand there's something relatively new with out west where there's flooding to actually pipe the floodwaters to places that have overused their aquifers and are out of water or, going desertification. Do you know anything about those ventures?
I'm not involved so much in that research now, but I definitely think that for communities and areas that have the infrastructure and the resources, that's possible. What I focused more on was riverine flooding, and I don't know for that area that would have been possible in Southwest Virginia just because of the lack of funds, and then also navigating existing infrastructure that we have. Okay, so I'll go ahead and pass it off to the next person.
Hi, everybody. My name is Benjamin Bridges. I'm an undergraduate student at the University of Tennessee, Knoxville. I am majoring in BCMB, which stands for Biochemistry and Cellular Molecular Biology. It's kind of a mouthful. I have been working with Vols Teach now. This is actually my 4th year, going into my 4th year with it. I actually heard about the Vols Teach internship when I was still at Pellissippi, which is the local community college here. And it was, at the time, it was just a summer job. I heard they were paying, $1,000 to come hang out, and I was like, I'm with it. So I went, and I spent the entire month of June helping lead and kind of conduct like STEM activities with middle school aged summer campers. And it was at that time that I really thought about it, because I had always known that I wanted to go into the STEM field. But it was really at that time that I kind of considered teaching, in some capacity. At the time, I thought that I might actually end up wanting to become a teacher. Right now, it's kind of moved more into kind of a backup plan role. I am actually pre-med right now, and I've always wanted to do medicine ever since I was little. The type of medicine that I want to do is obviously changed, a couple times, but right now where I've kind of landed is pediatric cardiology. I just love working with kids, and then I've always thought that the heart was the coolest organ, kind of ever. So I merged the two. Pediatric cardiology came of it, and haven't been able to look away from that since. I also, I also do neuroscience research at the university. It's more of a computational neuroscience role, so a lot of the time we're using deep learning programs to quantify different trajectory kinematics, which in layman's terms is how our mice move around a cage and use their senses and other sensory cues to kind of impact or encourage certain behavioral patterns, and those patterns are what we focus on. Yeah, that's kind of it.
Do you do any EEG related
We
stuff?
do not.
Okay.
No, that's a different lab.
Okay.
Yeah.
Did you do anything with open field behavior in mice?
We do not. I guess technically not open field necessarily, but part of the behavioral patterns that we do find is that our mice try to not touch the center of the cage at all, which is technically somewhat open field, but it's not open field, the open field that you're
Well, you can even do it in a cage, open
Right.
field behavior, but it has to do with their anxiety levels
Correct.
and so forth.
Yeah. When we do see a lot of the times we'll end up after we run our data through our code, it'll plot different heat maps of where the mice like to hang out the most, and it's actually very rare that you see them cross the center of the cage. They just hug the wall and walk around it most of the time. So,
Have you done anything, I forget his name now, but he actually spoke at a previous Science Cafe, who does the cockroach behavior, hiding under certain conditions.
no, I haven't seen that.
I think he's
Yeah.
got a joint appointment with the psych department, and David, do you remember? Psych and maybe EEB, I'm not sure.
Here, hang on, I've got the list of past events up. I had it a second ago. Let's see.
I thought it was pretty interesting doing behavioral research on cockroaches.
Cockroaches, yeah. That's the first time I've heard of cockroaches being used as a model organism. It's not very common, I
No,
don't think.
I don't imagine.
It's pretty neat.
let's see. Just trying to remember what year that was. Cockroaches. Oh goodness.
I think it was pre-COVID.
Yeah, that's what I was thinking, 2018 maybe. Yes, that speaker was Todd Freeberg.
Right,
Yeah.
that's it, Todd Freeberg.
Department of Psychology adjunct faculty at that time. Ecology and evolutionary biology.
I wonder if he's still there, it'd be fun to get him back and see what kind of progress he's made on cockroaches. And I like the dung beetle. Do you know the dung beetle lady?
I do not.
In EEB, she studies dung beetles. Again, I don't recall her name, but it's quite interesting study.
That's everything I have.
Catherine, do you want to,
Yes, I guess I'm wrapping it up.
you want to wrap it up for us here?
There you are.
You gotta change the camera, it's fine.
No, that's fine.
Let's see.
It's easy to change the camera angle, just tilt the screen, but, yeah. We've gone the full range here, so we're good.
That's A-okay. Okay, so my name is Catherine Kelton. I'm a freshman at UT, so all my experiences are pretty elementary compared to y'all's. It's been very interesting to hear though. But I guess my STEM journey kind of began in my high school. I'm from Murfreesboro, so I went to Oakland High, and we had the International Baccalaureate program there, and I joined that my senior year, and you're supposed to start as a junior, so it was already a fun little journey to do that. But I was in my environmental science, so it was a one-year class, thank goodness, and before that, I really didn't like science. I love math. Always have been a fan of math because it doesn't change. But my science was always something I was not a strong student in, but environmental science, my teacher was amazing. We had a lot of hands-on experiences. Ms. Gardner actually reminds me a lot of my teacher. I was able to do lots of studies with like the creek out in front of my school. We got to go outside and do a lot of field work because, yeah, we were able. Most of my high school experience was during COVID, so we couldn't do that at first. But senior year, we were able to be outside as long as we were social distancing. We could do experiments, stuff like that. So I did a creek water study on we did testing the water levels, trying to see if different bacteria that are in there. I did a lot of one-on-one lab stuff for my diploma. My study was over bean seeds or something like that. Some climate conditions. That was a lot of fun. Yeah, that was my biggest part of my STEM journey. I mean, I'm just a freshman, so I'm really excited to see what else I'm gonna do. But I'm a math major. I probably should start off by saying that. With a minor in education, I want to be a high school teacher. Kind of hopefully continue the tradition of having a strong teacher, teaching stance. Yeah, I don't honestly know what else. Yeah, IB really helped me get fully grasp working with the real world studies and being able to kind of broaden my knowledge to more of what I could have done had I not done it. So that's a nice thing. I think does Bearden have an IB program?
West does.
West does, okay. I'm not from here, so obviously don't. But yeah, I don't really have much else, but yeah.
Thank you.
I don't honestly know what it sounds like.
Yes, ma'am. Close it out.
Well, let's give all those speakers. That's good. Let's see. So I was, Sandra's with us. Actually, before I do that, Sandra, do you have any questions for any of the speakers? Let's see. Have you unmuted yourself? Yeah. Can you hear us? Okay.
Yeah, I can hear you now.
Okay.
I have the earplugs in. I have maybe a question request. I'm working with NSS and NIH and different people with the National Space Society, and we've been working on maximizing the immune system for astronauts going into outer space when radiation hits their body, as well as staying healthy on Earth. But there's one of the ladies in Hawaii who's in the working with us keeps wanting STEM or STEAM, both, to be involved in this. She's really been bringing that up quite a bit lately. And there's a guy, Kai Stats, in Arizona with the biosphere that is doing I guess it was the prototype for the larger biosphere that he's putting together I guess a situation or environment enclosed that would be like Mars, living on Mars. So my request or question is if any of these speakers know of anyone that would like to put a diet together, they can go to Space, SPACEDGE Academy, just Google that, and the contest. And if you know of any students for next year's contest, they get to go do an analog mission out in the Mojave Desert as part of the prize, and they have some prize money as well. So we're looking for people to be involved in that. So it sounds like any of your speakers may have access to students and they also want to bring it into the high school and middle school, even elementary. We have to work with the age of 18 for the winners to do the low analog vision. But anyhow, that's sort of my question or suggestion to anyone that might have access to that with students.
Nick, perhaps I should connect you two together. Okay, so I'll exchange or trade some email addresses, Sandra, with you and Nick, who's heading up the STEM group here. So yeah, we'll connect you with the resources that you need, Sandra.
Okay, that's great. I know there's a big group, and I listened to the Friends of Oak Ridge National Lab this morning. They have a luncheon and meeting usually from 11:30 to about 1:30, whatever day of the month this is. And it's a great group. There were 36 on Zoom with that today, as well as a good group at the meeting. And that's a great thing to be involved in. But they also were talking about STEM before the meeting and their business part of it. So I guess STEAM is becoming quite a thing these days. So anyhow, yeah, send me whatever you have or what connections to get students involved, and how we'll begin to integrate the younger population into the contest. We'll have to work on that, but Lynn in Hawaii is very involved, and Bonnie in Chicago. So, and then we have a guy at NIH here, and Bill's in Atlanta. So there's people all over working on it, and it'd be great to become part of it with our contest.
Okay, thank you, Sandra. Hopefully we'll hear more about that in the future. For next week, it's 7 days plus one. Wednesday, October the 19th is when we're supposed to have the STEM station. And let me go ahead and, have you muted yourself? Yeah. Next week, on Wednesday, the STEM stations for K through 8. I haven't seen if anybody has signed up. I didn't see until yesterday the number that was here. Do we have an idea?
I don't have access to that, but I'll ask my coordinator.
Okay. So yeah, I've been sharing that information around, but I'll be basically sending out what would be the reminder message for that. So hopefully we'll get some responses from that. But this is going to be up, not here at this location, at Hines Nature Center, at the Visitor Center building. And the great room there has seating for 108, but that's where the stations will be. And then there's a glass wall essentially that separates that great room from the back patio. So hopefully we'll have cooperative weather and basically have our hot drinks and stuff set up outside on the patio, and then people will be able to observe what's going on through the wall, the parents being inside. That's kind of the plan we've got. So
We also created 2 stations for older students and adults as well, just in case they brought their older siblings or parents.
okay, all right.
It's not just K through 8.
I was trying to anticipate the needs and the limitations and where the boundaries were. So I was assuming that students would be on the inside and a parent would be with them, but we'd have potentially other visitors who kind of that maybe shouldn't mix with the students. So that was kind of the idea there. Anyways, that'll be October the 19th. And then I have the next Science Cafe meeting after that will be back, will be in November 17th. And a professor from UT had just recently retired from the finance department, Raymond DeGenero, and he'll be talking about the science of the stock market. So that'll be the first time we've had a speaker from the finance department, but Ray's been coming to the Science Cafe for about 7 or 8 years, and just basically some topics are of interest, some topics are not, but whenever there's something he likes, he's been coming. I didn't even know he was UT professor for a couple of years, so yeah, that was on the low. But he just recently retired, and so now that process is complete. And he says, okay, you can add my name to the flyer. Before it was all top secret. Anyways, that'll be November 17th back here in this room at 5:30, and that's on a Thursday evening. And I've been talking with, we'll probably not do a topic in December, and we'll pick back up next year. I don't have any speakers solidly locked in or topics solidly locked in. So again, if you or somebody that you know, your colleague or somebody that would like to be a presenter for us at a future Science Cafe meeting, just reach out to me.
Were you able to get a hold of that lady in Chattanooga at the aquarium who does research on plastics in the rivers?
I've not been able to get in touch with her yet,
Okay.
so but
I
that's.
think that might be an interesting topic.
Especially the Tennessee River where there's a ton
Yeah,
of plastics.
yeah. She's
Yeah.
done some research on that.
Yeah. Yeah. Were you going to send me the contact information or for her or?
I don't remember.
Okay.
All I remember is I read an article about her in one of the
Okay.
science journals, so.
Is it one of the articles you sent me?
No, I think it wasn't
Okay.
on astronomy or the cosmos,
Okay.
so I didn't send it to
Okay,
you.
we'll connect again about that. I remember our conversation, but I guess I didn't realize I had the ball. Anyways, yeah, I've been, some of the topics that we've, have been trying to get speakers for a while, the Gulf oil spill, what's it been, 11, 12 years ago now? How's the biology on the Gulf floor? You know, is there this much oil still down there, or is it dissipated and diluted throughout the Atlantic Ocean? What's going on down there? How's the biology, or does it survive? And that's a topic that I've been looking for a speaker on.
What's the contract and that angle in Earth and planetary
On that
sciences?
angle. On that angle, okay. And then the bees, that was another one. If you've been out of bees for a while, or been out of pollinators, out of insects for a while, but
Always happy to talk about bugs. Just
hey, that's a possibility, or someone that's doing the research right now. That was another topic, and we get requests for different things all the time. Does anybody know anything, or have you ever heard about the process of recycling and processing garbage waste in Sevier County. Are you familiar with that? They have different classes of recycling that goes on, and the recycling and the processing of garbage in Sevier County is like the second best recycling center in the entire country. There's one facility in California that it tops it.
Wow.
But they basically have a process of pulling materials out and recycling the vast majority and composting everything that, and separating the garbage. You can, in Sevier, here in Knox County, you have to separate your recyclables. There, they have the ability to actually take just random garbage and pull all the recycled materials out of it in a highly efficient way. Yeah, I'd love to
Field trip.
yeah. Which, oddly enough, my mother used to live in Sevier County, and she had an apartment that was really close to the recycling center. So bring your clothespin and down the butt. Anyways, so these are the upcoming meetings, and again, our website, knoxsciencecafe.org, and you can go there. My contact, there's a link at the bottom that will come to me. And but again,
I'll also send out an email to all the presenters and
okay.
some access.
Super, yeah. And so, yeah, please share about us, about the general topics, but also I'm interested in what we can do in the future when we were talking about the potential of doing something with school or whatever. And these meetings, they might not be highly attended today, but I think of this as like a framework to where we can do this again as we get people that want to champion STEM in their own classroom. Yes, Sandra?
The Knoxville Technical Society that meets at the Crown Plaza in Knoxville, it was before I left there, so it's been a year ago. But they had a speaker from that recycling facility. It was excellent. You might get in touch with them and have him come and talk.
Another attendee that attends here and attends that meeting is actually how I found out about it. And he gave me the name of the speaker that was at the Crown Plaza a couple of years ago. And I haven't received any response from him, but I have reached out to that speaker. He was one of the ones that was actually helped to develop the process and implement the process that they have. So apparently he doesn't like email. He likes garbage, but he doesn't like email. Email's full of garbage though, so that should come very, very natural. But anyways, anybody have any other thoughts or questions or comments? Don't forget, grab you a bumper sticker and one of the little brochures, and we don't generally like leftovers, so grab you a sandwich and eat it on the way home, whatever. Anyways, thank you everyone for coming, and we sure appreciate you.
Thank you.
Thank you, everyone.
Sandra, while you're online,